Now random forest model. So random forest is a supervised learning algorithm. It has two variations. One it is used for classification problem and other is used for regression problem. We already knows about the classification and regression problem. Okay, so it is one of the most flexible and easy to use model. It creates decision tree on the given data sample, gets prediction from each tree, and select the best solution by means of voting. Okay, it create the decision tree. You can see this picture. There is some instances, fruit instances. Okay, so for this we create a multiple decision trees are there. Decision or decision tree one, decision two, decision tree three, two, and that's the decision tree n. There are we created n decision trees. Okay, whenever we create a multiple decision trees, then we have multiple output from each decision tree. Okay, there are so many outputs are there. Like we have a decision tree output apple, which is belong to class A, you can say. Okay, and tree two output is apple. Okay, which is belong class A, and N3 we have output banana. Okay, which is considered as class B. Now there is one thing, new thing here, voting. Okay, we find out the best solution. How can we find out? Majority of the class, majority of the output from multiple decision trees. So there are the two, there are the majority of apple output of apple. That means class A. So majority of which class? Class A. So we can identify the majority voting and we produce the final class. Okay, which will be here class A apple. Okay, so it is a good it is a it is also a pretty good indicator of the feature importance also. Random forest algorithm combines multiple decision tree, as we can say, as we discuss here, resulting in the forest of the tree, hence the name as random forest, because there are the multiple decision trees are there. That's why we can say uh, we can identify this method as a random forest tree. The random forest classifier, the higher the number of tree in the forest results in higher accuracy. Okay, so this is the basic concept behind random forest models, or you can say algorithms. There are so many decision trees created for the given instances, and after that we find out the after that we created creation of the all decision trees, we get the uh, each output of the each decision trees, and we can apply the voting, majority voting, and then we will get the final output. Okay, there are some steps uh, in the random forest algorithm we follow. Step number one, in the random forest model, subset of data points and subset of features is selected for constructing the each decision trees. Okay, so firstly we select the subset of data points and subset of features. Okay, for construction of the each decision tree. Simply put, n random records and m features are taken from dataset having k number of records. Okay. Step number two, individual decision trees are constructed for each sample. Okay, we created individual decision trees for each sample. And step number three, each decision tree will generate on output. Okay, After that, final step is final output is considered based on the majority voting, or you can we can apply averaging for the classification as well as regression respectively. Okay, so these are the simple method we have to follow for whenever we apply random forest algorithm. There are some advantages of this method. So random forest algorithm can be used to solve both classification and regression. Okay, it is considered as very accurate and a robust model because it uses larger number of decision trees to make predictions with high accuracy. Random forest takes the advantage average of all predictions made by the decision trees, which cancel out the bias. Okay, so it does not suffer from the overfitting problem here. Remember this thing. Okay, so there's no any biasness. So there's this method. Whenever we apply this method, so there is no any overfitting problems arise. Okay, so random forest classifier can handle the missing values also. There are two ways to handle the missing values. First is to use the median value to replace the continuous variables, and second is to compute the proximity weighted average of the missing value. That means you can say where is the maximum values, same value arise in the data set. So proximity weighted average value of the missing values. We can replace with this. Okay. Random forest classifier can be used for the feature selection also. It means selecting the most important features out of the available features from the training data set. Okay. There are some advantages of the random forest, so must be there some disadvantages also. Okay. So some disadvantage of the random forest method. The biggest disadvantage of the random forest is to computational complexity. Computational complexity. Why? Random forest is very slow in making prediction because there are larger number of decision trees are used to make prediction. Multiple decision trees are generated and multiple decision trees are generated your own output. All the trees to in the forest have make prediction for same input and then perform voting on it. So it is a time consuming process. Okay. So this is the most biggest disadvantage is uh, computational complexity. Next one is the model is difficult to interpret as compared to decision tree, where we can easily make a prediction as compared to decision tree. Okay. Next is KNN algorithm, K nearest neighbor algorithms. K nearest neighbor is one of the simplest machine learning algorithms based on supervised learning technique. KNN algorithm assumes the similarity between the new cases, new data, and available cases. Assume the similarity between new case, new data, and available case or available data, and put the new case into the category that is most similar to the available category. Remember this thing, okay? KNN model assume the similarity between new data and available data and put the new case or new data into the category that is most similar to the available category. Okay, so that is the basic concept behind the KNN model. KNN algorithm stores all the available data and classify a new data points based on the similarities. This means when new data appear, then it can be easily classified into a well-suited category by using KNN algorithm. KNN algorithm can be used for regression as well as for the classification, but mostly it is used for the classification problem. KNN is a non-parametric algorithm, which means it does not make any assumptions on underlying data. Okay. This is the simple pictures, and with the help of this picture, we can try to understand KNN concept. Okay, there is also KNN is also known as lazy learner algorithms because it does not learn from the training data set immediately. Instead, it stores the data set, and at the time of classification, it performs an action on the data set. Okay, so with with this reason is it's also called the learner data set. KNN algorithm at the training phase just store the data set, and when it get new data, then it classifies that data into a category. Okay, so that is much similar to the new data. So this is the basic concept behind the KNN. Let's we take an example regarding this picture. Suppose we have an image of a creature that looks similar to cat and dog. This image, you can you identify this image? It is cat or dog? Is it cat or dog? No, because this is a uh, creature. Okay, creature of any image. Okay, just like you can similar to the cat or dog, but you don't know what is what is it. Okay, so we want to know either it is cat or dog. So for this identification, we can use KNN algorithm here, as it works on the similar measure on on a similarity measure. Our KNN model will find the similar features of a new data set to the cat or dog images. Okay, this image we can compare with the data set which is cat and dog also, and we can identify similarity of this image with all of these two images, dog and cat images. Okay, we can identify similarities. Okay, after identification of the similarities between this creature of the image and available images, okay, based on those most similar features, it will put it either dog or cat. So predicted output will be cat here because this image is almost similar with the cat image. Got it? So this is the basic concept behind the KNN classifier. Why do we need a KNN algorithms? Suppose there are two categories, category A, category B, and we have a new data set, new data point x1. So this data point will lie in which of these category? To solve this type of problem, we need a KNN algorithm. With the help of KNN, we can easily identify the category or class for the particular data set. Look at this picture. Category 1 data points and category B data point. This is the new data point. Now we can classify for this new data point. There is a problem to find out the category. Which one category lie by this new data point? Category A, category B. Okay. So after applying KNN, we can identify new data point assigned to category 1 because this new data point almost similar with the category A. So that's belonging to category A with features X and X1 and X2. Okay. How does KNN works? There are some steps we have to follow whenever we apply KNN. So select the number K of the neighbor. Select the number K of the neighbors. Okay. So step number 2, calculate the Euclidean distance of K number of neighbors. Okay. We all know the Euclidean distance. We already studied this formula at, I think, 10th or 12th standard. Okay, it is whenever we want to calculate the distance between two data point. Whenever you want to calculate between 2 point distance, so we can use this formula. Step number 3, take the k nearest neighbor as per the calculated Euclidean distance. And step number 4, among these k neighbor, count the number of data points in each category. And next step, assign the new data point to that category for which the number of neighbor is maximum. Okay, our model is ready. Suppose we have a new data point like this already. Okay, we need to put it required category. Okay, category A, category B. Features are x1 and x2. First, we will choose the number of neighbors. So we will choose the number of neighbors k is equals to 5. Okay. Next we will calculate the Euclidean distance between data points. The Euclidean distance is the distance between 2 points we already discussed, and this is the formula Euclidean distance between A1 and B1. Okay, A1 and B2. A1 x1 y1, sorry, A and B x1 y1 and x2 y2. We try to find out the distance between A and B. So this is the formula underscore uh, x2 minus x1 whole square plus y2 minus y1 whole square. Okay. By calculating the Euclidean distance, we got the nearest neighbor. Okay. As three nearest neighbor is in category A and two nearest neighbor in category B. These are the nearest. Okay. This one and this one, category B, and this one, and this one are from the category 2. These are having less distance. Okay. So now, as we can see, three nearest neighbor are come from category A, hence this new data point must belong into the category A. So that means this new data point will consider as category A because number of neighbor, maximum number of neighbor are having minimum distance from this point. Okay. So how to select the value of k and kn? Below are some points we discussed. There is no particular way to determine the best value for k. So we need to try some values to find out the best out of them. The most preferable value for k is 5. Most of the cases we have to use 5. A very low value for k is such as k is equals to 1, k is equals to 2. Whenever we use k is equals to 1 and 2, might be possible it can be produce some noise and lead to the effect of the outlier in the model. Okay, and large value for k are good, but it may find some difficulties. Okay, so most preferable is 5. There's some advantage of knn. It is a simple to implement. It is robust to the noisy training data. It can be more effective if the training data set is large. Whenever we deal with the large data set, it is more effective algorithm. Okay. There is some disadvantage of the kernel. It always need to determine the value of k, which may be complex sometime. Okay. And the computation cost is high because of calculating the distance between the data point for all training samples. So computation cost will be high. So these are some advantage and disadvantage of the KNN algorithm. Yes. Now we are discuss about regression. We already discussed about the classification technique, which is also under the consideration of supervised learning technique. This is also the regression technique is also under the consideration. Supervised learning technique. We already discussed in previous class supervised learning technique having two types of technique. First one is classification, second one is regression. Classification, that means whenever you discuss about we having an example to understand the classification, like email spam classification. Useful mail uh, we have received in the inbox, and unuseful mail we have received in the spam. So that is the example to understand the classification model. We already discussed various classification model like naive Bayes, KNN model, SVM model, logistic regression model, and decision tree. Also, we already discussed about these model. Now we are talking about regression. Regression analysis is a statistical method to model the relationship between dependent, we can say target variable, and independent variables with one or more independent variables. There are maybe might be possible. There are so many independent variables are there. Okay, so it's a relationship. It's a statistical method, and it's represent the relationship between dependent and independent variables. Okay, for example, for example, we want to learn, we want to develop a machine learning model. You can say classification model or regression model. So must have some knowledge about the programming language and data analysis. Okay, so data analysis and programming analysis are the independent variable, but when development of the model is the dependent variable, because whenever you have a knowledge with programming, system programming, and data analysis, then you have to develop the machine learning model. Okay, if you don't have the data analysis knowledge, or you can say system programming knowledge, so you cannot develop the machine learning project. Okay, so this is the basic example to understand the dependent and independent variables, or it's a relationship between dependent and independent variables. And we already said there are more than one independent variable maybe exist. Okay, so regression analysis help us to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variable are held fixed. Okay, so with the help of regression analysis, we can understand the how the value of the dependent variable is changing, how the value of dependent variable is changing corresponding to a independent variable when other independent variable are fixed. Okay, so that is the dependent and independent variable, and we can learn about the we can understand the uh, how the value of dependent variable is changing corresponding to the independent variables. Okay, like machine learning project is the dependent variable, and system programming and data analysis knowledge are the independent variables. So uh, how can we variation of the changing of the dependent variable is depend on the all these independent variables. Okay, it predicts continuous and real values. For example, temperature, age, salary, price, etc. Temperature, whenever you want to develop a model to identify to identify the temperature, age, salary, and price. So these are the parameter will produce the value, will gives the value in a real form, continuous. It's give the continuous value like temperatures. For example, nowadays temperature is surrounding 44.6. 36.6. So these are the real value, and these are the variable. Okay, these are the changing in time by time. Okay, for example, you can check the temperature in morning time. So I think it will be for example 33.6. Okay, whenever you find out the temperature at 12 o'clock, so it will be 44.9. And whenever you calculate the temperature at 3 o'clock, so might maybe possible it will be 40.6 something. Okay, and at the evening time it will be reduced, and at the night time it will be also reduced. So this is the variable form. Okay, that is the changing at particular point. Okay, similarly, age variable is also real value. Uh, for example, you want to calculate the age calculator. Calculate the age by age calculator. So, for example, if you want to insert 03031987, so with the current date, age calculator calculate the age by with your birth date. Okay, so it will be might be possible. It will be after calculation. It will give the uh, value, real value. For example, 33.7. That means 33 years 7 months. So that is the real value. Okay. Similarly for the price and salaries. Okay. For example, suppose there is a marketing company, who does various advertisement every year and get sales on that. Okay. The below list shows the advertisement made by the company in the last 5 years and the corresponding sales. So a company, uh, a company, a $90 expend on the advertisement and sales will be $1,000. Similarly, whenever company A expend the $120, then sales will be increased $1300. Okay. Whenever company A expend the $150 on the advertisement, and company sales will be also increase $1800. Okay. Similarly, for the $100, it will be 12,000, $1,200 sales, and $130 for the advertisement, then it will be 1380. Now, with the help of these example, with the help of these example, we can calculate whenever company A expend the $2,000 on the advertisement. So what will be the sales? So we can predict the value of sales at the time of whenever you expend the $200 on the advertisement. Okay, with the help of previous expenditure on sales on advertisement and getting the sales. Okay, so this is the example of the regression. I hope you all better understand the uh, regression analysis with the help of this example. Okay, now the company wants to do yes, same thing. Company wants to do the advertisement of $200 in a year 2019, and wants to know the prediction about the sales of this year. So to solve such type of prediction problem in machine learning, we need regression analysis. Similarly, if you want to expend $4,000 in year 2024 and want to know the prediction about the sales of this current year, so you can also calculate with the help of this prediction model. That is under the considering regression analysis. Okay, so regression is a supervised learning technique which helps in finding the correlation between variables and enable us to predict the continuous output variable based on the one or more predictor variable. So basically, it's find the correlation between the variables. Okay, and enables to predict the continuous output variable also based on one or more predictor variable. Okay, it's mainly used for prediction, forecasting, time series modeling, and determining the causal effect relationship between variables. So remember all these things. Whenever we want to whenever you want to work with the some time series analysis and we want to create the model, time series model, so you can go with the regression analysis. Okay. In regression, we plot a graph between variables which best fit the given data point. Using this plot, machine learning model can make prediction about the data. Okay. In simple words, regression shows a line or curve that passes through all data points on target predictor graph in such a way that the vertical distance between the data point and regression line is minimum. Okay, so the distance between data points and the line tells whether a model has captured a strong relationship and not. Okay, so basically this line shows the strong relationship between all data points, which is very on that particular line or nearby that particular line. Okay, so regression shows a line or curve that passes through all the data points on target predictor graph. Okay, in such a way that the vertical distance between data points and regression line is minimum. Okay, so that is the main concept behind the regression. Some example of the regression can be as prediction of the rain using temperature and other factors. You can calculate the you can predict the rain at the mid June mid June on the basis of temperature is a basic parameter, basic variable, and other factor also like number of trees in our city, number of trees in our country. Okay, so there are so many other parameter, other factor also you can consider whenever you want to develop a model to predict the rain. Okay, at the time of rainy season. Okay, so with the help of temperature and other parameter, you can predict the rain. Okay, for example, if you want to predict the welcome of rain, for example, if you want to calculate the time of rainy season, starting rainy season in Vadodara, 15th of June. So you can predict the rainy season with the help of that particular prediction model and some supporting factor also, temperature and other factor. Okay. Second one is market trends. For example, we already given the example of share market price prediction model. Whenever you want to develop the share market price prediction model, so you can go with the regression. Okay. So and prediction of road accident due to the rush driving. It is also possible whenever you want to develop a prediction of road accident. In a, for example, you want to develop the model for Ahmedabad Mumbai highway. Okay, so you can predict the model, you can predict the road accidents due to the rush driving on that particular highway. Okay, with the help of some variables, with the help of some factors. That's called the independent variable. Road accident depend on the road accident will be considered as a dependent variable, but there are some factors. These are called the independent variables. Okay. With the help of these independent variables, we can calculate the number of road accident at that particular highway. So these are the example to understand the regression. Okay. These are the our daily routine uh, incidents like road accident. So you can develop the prediction model for that particular incident, road incident. Okay, you can develop the model for the temperature prediction. You can develop the model for the share market price prediction. You can develop the model for the um, rainy season. Okay, so these are the basic example to understand the regression in a better way. Okay, there are some terminology which are related to the regression analysis. First one is dependent variable. The main factor in regression analysis which we want to predict or understand is called dependent variable. It is also called the target variable. The main factor in regression analysis which we want to predict or understand is called the dependent variable. Okay, and for example, in this model, road accident model. So road accident is called the dependent. For example, we want to develop the road accident predictor. Okay, so road accident is the dependent variable. Okay, there are some other variables. Okay, these on the basis of these variable you can develop the predictor. Which predictor? Road accident predictor. Okay, so these factor which affect the dependent variable or which are used to predict the value of dependent variable. Okay, are called the independent variable. You can say predictor. Okay, outlier. Outlier is an observation which contain either very low value, either very high value in comparison to other observed value. Okay, outlier is an observation which contains either very low value or either very high value in comparison to other observed value. Okay, so an outlier may hamper the result, so it should be avoided. Multicollinearity. If the independent variables are highly correlated with each other than other variables, then such condition is called the multicollinearity. It should not be present in the data set because it's create the problem while ranking the most effective variable. Overfitting and underfitting. If your algorithm works well with the training data set, but not well with the test data set. Remember this thing. If your algorithm works well with the training data set, but not well with the test data set, then such problem is called the overfitting. And if your algorithm does not perform well, even the training data set. Okay. Second condition is if your model does not perform well, even with the training data set also, then such problem is called underfitting. Okay. So this is the basic difference between underfitting and overfitting. So these are the basic terminology where whenever you want to develop the regression model, so these terminology will be entered with your model, entered with you. Why do we use regression analysis? Regression analysis helps in the prediction of continuous variable. There are various scenarios in the real world where we need some future prediction, such as weather condition, sales prediction, marketing trends, etc. For such case, we need some technology where we can prediction more accurately. We already given the example. We already discussed about the example of weather condition. If you want to predict the rainy season, when will we start the rain in our Vadodara? So you can um, predict this rainy season whenever it will be start in Vadodara. So we can develop the weather predictor, okay, with the help of uh, some other factors. Okay. Similarly, sales prediction we already discussed the sales prediction. Whenever you expend some money on the advertisement, your sales will be increase. Okay, uh, marketing trends, share price market prediction. Okay, So these are the basic example. There, there you can make a prediction more accurately. Okay, so that will be very helpful for all of us. So for such case, we need regression analysis, which is a statistical method and used in machine learning and data science. Okay, so there are some reasons for using regression analysis. Regression estimates the relationship between target and independent variables. We already discussed this thing, and it is used to find the trends or patterns in the data. Okay, and with the help of relationship between the variables. Okay, you can develop the pattern. You can find the trends in the data. It helps to predict real or continuous value. Okay, in the classification, you cannot predict continuous or real value because there will be developed the class. Okay, class 1, class 2. Okay, whenever you develop the multi-classification, so class 1, class 2, class 3, class 4 may be possible, class n. Okay, but if you want to simple classification, there will be two class. Okay, pass, fail, ham, spam, etc. Okay, by performing the regression, we can confidently determine the most important factor, the least important factor, and how each factor is affecting the other factors. With the help of regression, we confidently determine the most important factor whenever you want to develop the predictor. For example, weather predictor. Okay, so there is the most important factor, I think, temperature. There are so many other factors also, but most important factor will be temperature as per our knowledge. And we also calculate the least important factor. Okay, whenever you don't include that factor, so model will be give the answer accurately. So you can calculate the least important factor also. Okay, and as well as how each factor is affecting the other factor also. You can calculate with the help of regression also. It's okay. So type of regression. There are some types of regression. First one is linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression, rigid regression, lasso regression, and logistic regression. Okay, so there are the basic regression types. Linear regression. Linear regression is a statistical regression method which is used for the predictive analysis. Okay, it is one of the very simple and easy algorithms which works on regression and shows the relationship between continuous variables. So it's a very simple and easy algorithms which works on the regression and it's brand that strong relationship between continuous variables. Linear regression is used for solving the regression problem in machine learning, and linear regression shows the linear relationship between independent variable which are very which will be very in x-axis and dependent variable considered in y-axis. Okay, hence called the linear regression. If there is only one input variable x, then such linear regression is called simple linear regression. If there will be one input variable, such linear regression is called the linear regression, simple linear regression. And if there is more than one input variable, such consider as a linear regression is called multiple linear regression. Okay, so this is the basic difference between simple linear regression and multiple linear regression. Simple linear regression having only one input variable and multiple linear regression having more than one input variable. The relationship between variables in the linear regression model can be explained using the given image. You can see this picture. X vary the experience and salary indicating the Y indicating the salary. So there is the one variable experience and another will be salary. So here we are predicting the salary of the employee of an employee on the basis of year of experience. On the basis of year of experience. Okay. So there will be the experience, 2 year experience, 4 year experience, 6 year experience, 8 year and 10 year experience, and salary will be 40,000, 60,000, 80,000, 1 lakh, 120. Okay. So whenever you have the experience 2 year, then your salary will be approx 38,000. Whenever you have experience 4 year, your salary will be approximate 58,000. Your experience, you have experience approx 6 year, then your salary will be 80,000. And 8 year experience you have, then salary will be approx 98,000. Whenever you have 10 year experience and salary will be 120. Okay. So this is the basic example to understand the linear regression. And whenever you have a experience 2.5 year experience, so your salary will be also calculate with this relationship, it will be approximate 45,000. Whenever you have a experience 4 year 2 month, and salary you will calculate with the help of this model, and it will be approx 59,000. Okay. Whenever you have a experience 5 year experience, so salary will be approximate 63,000. So this is the basic model. And this is the basic relationship between, you can say, experience and salary. Okay, so this is the model where we can predict the salary on the basis of independent variable experience. Okay, there are so many data points. You can see here green data point. These are the salary point, indicating the salary point. Okay, salary. This is the relationship between experience and salary. So this point, for example, if you have experience 1.9 year experience, so this point indicating the salary also 20,000 approximate. Okay, and so there are so many examples, so many data points which are indicating the relationship between salary and experience. You can say this relationship in mathematical form: y is equals to ax plus b. Y is equals to that, y means dependent variable, you can say target variable, and x representing the independent variables like experience in this picture, and you can say also predictor variable also. A and B are the linear coefficient. Okay. Now there are so many data points, and whenever you want to develop that predictor model on the basis of experience factor, you can say variable, okay, with the target variable salary. So there are so many data points, and we try to make a model with best fit line. Whenever this line create with the help of the predictor model, almost all data points will vary along with the that particular line. Okay, so you can see here, this is the best fit line, all these data point nearby with this line. So you can say this is the best fit model. Okay, whenever this line in this form, so there is no any data point will be lie on this line, so that is not a good fit line. Okay, so this is the example to best fit line, understand the best fit line. Okay, so there is some application also, application of linear regression. We already discussed this thing, analyzing trends and sales estimates, salary forecasting, real estate prediction, and arriving at ETA, that means estimated time of arrival in traffic. Okay, so for example, I think everyone knows about the where is my train application. Okay, so in that application you can see your train whenever you want to go from Vadodara to Mumbai at the time 5 p.m. today. So you would just click on that source and destination name and find out all this train with ETAs, expected estimated time of arrival of that particular train. Okay, so this is the best example to understand the linear regression. Okay, next one is logistic regression. Logistic regression is a supervised machine learning algorithm which is mainly used for the classification task, where the goal is to predict the probability, which is having the goal to predict the probability that has that an instance of belonging to a given class or not. Okay, logistic regression model having the goal to predict the probability. Okay, that has an instance to belonging to a given class or not. It is a kind of statistical algorithm which analyzes the relationship between the set of independent variable and dependent binary variable. Okay, relationship between independent variable and dependent binary variables. It is very powerful tool for the decision making. For example, email spam or not. Email spam classification model. It's one of the example to understand the logistic regression. Whenever you have received a mail, so that model classify the that particular mail that is the useful or not unuseful. Whenever this mail will be maybe useful, that will be received in your inbox. For example, you got any fake mail, unuseful mail, so that will be received in your spam. It is used for the classification algorithm. Its name is logistic regression. Okay, it's referred to as regression because it takes the output of the linear regression function as input. It takes the output of the linear regression function as input. Got my point? It's referred to as a regression because it's having the name logistic regression. Okay, so regression means what? Why we use this regression word here? It's referred to as regression because it's take the output of the regression function as input, because linear regression function have a real value, continuous value. Okay, so continuous value having as the input and uses the sigmoid function to estimate the probability of that particular given class. Okay, so what is this sigmoid function? The sigmoid function perform the role of the activation function in machine learning, which is used to add non-linearity in the machine learning model, which is used to add non-linearity in the machine learning model. Okay, because we are working on the classification, but you have the input from the linear regression function output, for example, real value, continuous value as an input and uses sigmoid function. Why we use this? Because we want to add some non-linearity in this machine learning model. Okay, basically this function determine which value to pass as in output and what not to pass as output. This is the basic function of the sigmoid function. What value to pass as output and what not to pass as output. Okay, so that is the main concept behind the logistic regression. The difference between linear regression and logistic regression is that linear regression output is the continuous value, okay, that can be anything, while logistic regression predict the probability that an instance belonging to the given class or not. Okay, for example, email spam classification might be possible it spam unuseful mail you have received in your inbox as useful mail. So that is the probability. Okay, you can say logistic regression predict the probability that an instance belonging to the given class or not. Okay, for example, some of the time we have received any useful mail as a spam also. Okay, so that is one of the example to understand the logistic regression because there is the probability. Okay, Real life example of the logistic regression, one of the best example to understand the logistic regression, like email spam classification. Okay, medical researcher want to know. Another example is medical researcher want to know how exercise and weight impact the probability of having a heart attack. There is a scenario. Okay, some of the researchers want to know how exercise and weight impact the probability of having a heart attack. To understand the relationship between predictor variables, which means exercise and weight, and probability of having a heart attack, target variable. Okay, researchers can perform logistic regression. You cannot fix classification of that particular thing. Okay, on the basis of exercise and weight, you cannot classify the heart attack cases. Okay, so there may be a probability. Okay, so we can use the logistic regression here. The response variable in the model will be heart attack. Okay, and it has two potential outcome. One is a heart attack occur and heart attack does not occur. Okay, there is two things: heart attack occur, heart attack does not occur. The results of the model will tell researchers exactly how changes in exercise and weight affect the probability that a given individual has a heart attack. The researcher can also use the fitted logistic regression model to predict the probability that a given individual has a heart attack based on their weight and their time spent on exercise. Okay, so there is some terminologies which is involved in the logistic regressions. First one is independent variables. As we know, the input characters or predictor factors apply to the dependent variables predictions. The dependent variables, the target variables in logistic regression model, which we are trying to predict. Logistic function, the formula used to represent how the independent and dependent variable are related to one another. Okay. The logistic function transforms the input variable into probability value between 0 to 1, which represent the likelihood the dependent variable belonging to 1 or 0. Okay. Odds. It is the ratio of something occurring to something not occurring. It is different from probability, as probability is to ratio of something occurring to everything that could possibly occur. So there is the some terminologies which are involved in the logistic regression. Another one is log odds. The log odds, also known as the logistic function, it is a natural logarithm of the odds. In logistic regression, the log odds of the dependent variables are modeled as a linear combination of the dependent variable and intercept. Got it? Logistic regression. In logistic regression, the log odds of the dependent variables are modeled as a linear combination of independent variables and intercept. Got it? Coefficient, another terminologies which is which are involved in the logistic regression. The logistic regression models estimated parameters, so how the independent and dependent variable related to one another. Intercept, the constant term in logistic regression model, which represent the log odds when all independent variables are equal to 0. Maximum likelihood estimations, the method used to estimate the coefficient of the logistic regression model, which maximize the likelihood of the observation of the data given the model. Type of logistic regression. First one is binary, second one is multi, third one is ordinal. Binary having some this value like 0, 1, pass, fail. multi, that means cat, dog, lions, because they having the similar features like four leg, one tail, and similar structure of the mouth, I think. Mustache also. That's why there are some similar characteristics, all these cat, dog, and lion. So you can consider as multi logistic regression. Ordinal, low, medium, high. Okay. So first one is binary. When we, for example, when we have two possible outcomes, like our original example of whether a person is likely to infected with COVID-19 or not. Okay, it will be infected by the COVID-19 or it will not be infected by the COVID-19. Okay, like 0 1 category, pass fail category, ham spam category. Okay, and binary form. Okay, multi logistic regression. When we have multiple outcomes, say if we build out our original example to predict whether someone may have the flu, an allergy, a cold, or COVID-19. There is some possibility. It may be a flu, it may be an allergy, it may be a cold, it may be or COVID-19. So, okay, multi category. Ordinal, low, medium, high. When the outcome is ordered, like if we build our if we build out our original example to also help determine the severity of the COVID-19 infection, sorting it into mild, moderate, and severe cases. Low, medium, high, mild, moderate, or severe cases. Okay. How logistic regression works. The logistic regression model transforms the linear regression functions continuous value output into categorical value output using a sigmoid function which maps any real valued set of independent variables into input into value between 0 and 1. So you can say the linear logistic regression model transform the linear regression function continuous value output into categorical value output. Contiguous value output into categorical. Contiguous, that means they'll be entered with the real value. Okay. And into categorical value output, that means classes. Okay. Using with how can we done this with the help of sigmoid function, because we are using a sigmoid function, okay, which maps any real value set of independent variables input into value between 0 and 1. With the help of sigmoid function, we can change the real value set of real values of independent variables input, change in the class, which value vary between 0 to 1. Okay, this function known as the logistic function. Let's the independent input features. We can represent here some independent input features in this matrix form. You can see here x1 x is equals to x is the feature set is equals to x11 x12 x13 x1m, similarly x21 similarly and 1. Okay, so this is the matrix form representation of the input features. You can represent all features in this form. Okay, and dependent variable by having only binary value, which means 0 or 1. Okay, so dependent variable having output in the form of 0 and 1, you can represent by y is equals to 0 1 0. For example, if class 1, you have the class 1, so output will be 0, and class 2 output will be 1. Then apply the multilinear function to the input variable x. Okay, in that case we use this formula z is equals to summation of I is equals to 1 to n w of I x of I plus b. B is the biasness term. Okay, so x Here, xi is the ith observation of x. Ith observation of x. X are the feature set. Okay. And wi is the w1, w2 weight. Okay. Represent the weight or coefficient. B is the bias term, also known as intercept. Okay. So simply this can be represented as the dot product of weight and bias. So z is equals to w dot x plus b. Okay. So whatever we discuss in this linear regression, above discussed in is the linear regression. Now we use the sigmoid function where the input will be z and we find the probability between 0 and 1 or predicted by y. Okay. So you can see here one of the picture here as this figure sigmoid function convert the contiguous value variable data into probability. It means 0 and 1. This is the output. Okay. Y representing the output, x representing the features. Okay. So this there is the sigmoid function we are using, which are taking the some continuous value and transfer into the class, which may be 0 or 1. Okay. So these are some data points which are belonging to 0 class, and these are some data points which are belonging to class 1. Okay. And this is the value of y is equals to zero point 0.8, y is equals to 0.3. Okay. All these data points which are having below the value from 0.3, so which are considered as a class 0, and above the value 0.8, so these are considered as a class 1. Okay. So this is the description. Sigma of z tends toward 1 as whenever z is infinite. Okay. Sigma of z tends toward 0 whenever z tends to minus infinite. You can say this minus, and whenever it will be positive infinite, you can say this. Okay. And sigma of z is always bounded between 0 and 1. 0 and 1. Not greater than 1 and not less than 0. Okay. So where the probability of between a class can be measured by this. P of y is equals to 1 for 1. You can say sigma of z. With the help of this formula, you can calculate, okay, probability of the class. And whenever your output will be 0, then you can calculate by this 1 minus sigma of z. Okay. So this is the uh, way way to understand how logistic regression works. Okay. So there is some important role play the sigmoid function here. Okay, which are taking the some value in a continuous form and transform in the class form with probability. Got it? And another is independent variable and dependent variables. Okay. Next one is polynomial regression. Polynomial regression. Polynomial regression is a type of regression which models the non-linear data set using a linear model. Is a type of regression which models the non-linear data set using a linear model. Okay. It is similar to multiple linear regression, but it fits a non-linear curve, non-linear curve between the value of x and corresponding variable of y. You can see here, this is the curve, but not it is linear. It is not a linear. If you want to talk about linear, it will be just a straight line, but it is not linear. Okay. So suppose there is a data set which consists of data points which are present in non-linear fashion. So for such case, linear regression will not best fit to those data point. To cover this data point, we need polynomial regression. Obviously, whenever we use linear regression here, so some of the data points left from that best fit line. Oh, linear regression. But whenever we are having some non-linearity in data points, well, you can use the polynomial regression here. Okay, so in that case, you can cover all data points with that particular best fit line. Okay, so this is the equation of the polynomial regression. Y is equals to b of 0 plus b1 x plus b2 x power bx power 2. Okay, so b0, b1, b2 are the coefficient. Okay, in polynomial regression, the original features are transformed into polynomial features of given degree and then modeled using a linear model. Original features are transformed into the polynomial features of given degree. So that is a special feature of the polynomial regression. And after that transformation, that model will be that modeled uh, using the linear model, which means the data points are best fitted using a polynomial line. You already see this picture. You already see this picture. There's some data points which will be covered by the best fit line, polynomial line. Okay. So the equation of polynomial regression is also derived from the linear regression equation. That means linear regression equation y is equals to b of 0 plus b1 of x is transformed into polynomial regression equation. You can see here. Okay. Y is equals to y is the target output. You can say predicted output. B0, B1, Bn are the regression coefficient. X is our independent variables. Okay. The model is still linear as the coefficient are still linear with quadratic. Okay. So one of the important note here. This is different from multilinear regression in such a way that in polynomial regression, a single element has different degrees. Single element has different degrees instead of multiple variable with the same degree. Basic difference between multiple linear regression and polynomial regression is single element has different degree instead of multiple variables with the same degree. Got it?